Okay. Well, I'll go and check that out because I'm sure my order from Amazon is already going to be arriving from Skyline. But so worst that happens, I overpaid. At least I know. My wife thought it was ridiculous, but you can't pull off like the chili, what is it, spaghetti three-way, spaghetti five-way with any other chili. It's not right.
Yeah.
I mean, you can eat it. It's not like it's not edible, but it's like something about Skyline is just it's the right kind of spaghetti sauce for
Yeah.
that chili. You know what I'm talking about? So you do spaghetti, and then you put chili on top of it, and then you put like just 4 pounds of cheddar cheese on top, shredded, like a ridiculous amount of cheese on top, and then it all kind of melts in, and it's like this chili mac something or other, something like that. But Skyline chili, that's kind of a Cincinnati thing, but Skyline chili specifically has a unique flavor that just kind of goes right with it, I guess. I don't.
When I was younger, supposedly they put like chocolate.
Yeah, I've heard the same thing. I maybe even heard it from you. I heard it from somebody.
Yeah.
So I got a butter stain on my tie this morning. Look at that. I put too much butter on my English muffin. It was just dripping. So then I started licking it off. And then I put soda on it, but it doesn't look like it did the trick. All right. Well, so good news. I think good news. So we are not changing the schedule. Everything will stay copacetic. That's a word, right?
How'd that work out?
Well, so what the issue was is we were trying to help Homestead High School out. They have, I don't know the full extent of but they have two computer science classes there, like an intro to programming and an advanced programming class, and their teacher who usually teaches it, who we've had some interaction with here, so we've had a good relationship there. He's on a medical leave, so we don't know what the situation is, but I think he's going to be back. But they're on trimesters there, and so they're on their third trimester that goes from March 10th through June 15th, and they don't have teachers for these 3 classes, so the students wouldn't get to take the classes, but there's some other complexities like with human resources here and stuff like that. So what we're going to try to do is I'm going to try to provide them with some videos, which apparently aren't up anymore. We'll look here in a second. And then I can maybe become a resource for answering questions and stuff like that rather than actually being on campus there. So it'll all work out. But there was an effort trying to be made so the students didn't like miss out on the classes, because that then sets them apart, sets them back, and they have an arrangement with UWM for double credit for one of the classes. So we'll see how it works out. But it ended up being that it wasn't a possibility regardless of whether we can move this class or not. It was a human resources thing that there's a conflict with us teaching at another school and that kind of stuff.
Oh.
Is what it is. Well, I mean, I can't say I was looking forward to it. It was 5 days a week, so so I was trying to do a good thing by the high school students. But so in any case, you don't have to worry about anything, and hopefully we can still work something out with videos and.
What courses are you going to make available to them, or are you just going to make completely new content?
Well, I won't make new content. We're going to do 200, 250, and probably maybe if for their more advanced students that they can leak into it, the 300. This class. So 200 and 250 should cover their content for intro to programming and what they call advanced programming. So 300 would probably be beyond what they usually cover, but if they have 2 or 3 bright students, especially if they're going to end up doing independent studies, or I don't even know if that exists in high school, the idea of independent study. I know Homestead's a little bit different because they're kind of a college prep type school, but still being a public school. There's a school I work with in Philadelphia called Southampton Academy that is like a special school that you have to apply to and stuff like that. That's a high school that preps for some big computer science-y technology, not just computer science, but technology type schools, so engineering and things like that. So I work with them on programming stuff as well. Especially we have an app camp and an iOS programming course that we do there, but that's all remote, and we just have meeting times. So we'll see how it ends up hammering out. We'll go from there. All right, so you say if you go to what page are you trying to go to?
Just your YouTube channel.
Well, the channel as a whole.
Yeah.
So this guy. This is my playlists.
All I see is a subscribe button and a flag button. This is Michael Whitman, Computer Science Education for the Modern Student, and then underneath that it says this channel is good content. This is like the channel's homepage. Yeah.
That doesn't education for the modern student. That doesn't sound like. Does it have this purple thing? Me?
It's your account.
Okay. So it is me. What's the URL after YouTube?
/channel/UCCM_LSX
MSTXOWZLOOBKJZWA.
Yes.
Okay, so this is what you see right now.
Yeah, but without the uploads.
Right. So I wonder. So the stuff. So did this used to have stuff on it a couple days ago? I mean I never go to this page. I mean I think if you go into the course, our course. Let's go there here. Let's just see if that link takes us to the right place. This should give us a streaming lectures. Yeah, this should take you directly to the 300 lectures.
Okay.
Can you try that?
Yeah.
Like, I mean, I'm taking your word for it that main page had stuff on it before, because I never go to that page.
Yeah.
But I know the videos are there. Maybe it's just less. It's possible they changed something that I have to set up some sort of that work to get you to content.
Yeah.
Okay.
Except for one class is deleted. There's one deleted.
Yeah, I see. I have the same thing.
Okay.
I think that sometimes what happens is I upload the wrong video and it tells me this is a duplicate video and it's actually a lecture from a different class. Like I picked the wrong video, so that's why. Here, I'll even remove that. That should go away now. Okay, and I would assume from here you should be able to get to. I assume you can get to other stuff. Keep all my liked videos and saved playlists private. Oh, maybe is that the issue?
On mobile, it's still there. Yeah, mobile's
Huh. All right, let's let it cook for a couple days and just see if things change. And then we can start screwing with this. But as long as you still have access to our videos in here, and you should be able to get direct if you want to access any of the other courses, just let me know and I can give you the direct link to it. All right. So fix that. Covered. We don't need to reschedule, although now I know where every one of you is at every point in time on Tuesdays and Thursdays. Well, you had like a restrictive schedule, didn't you? Don't you work all day after this? Yeah, so you had a restricted schedule. So why would you lie about that?
I'm just saying somebody could have.
See, he's working all these extra hours so he can afford the finger monkey pet things, right? You got one on layaway for Christmas? I wonder what their lifespan is. They're $20,000?
They're really expensive.
That's kind of ridiculous. All right. So the rumor was I didn't push. Is that the rumor? mean, it shouldn't have made a difference. That was just our final. Okay, so this is working TOH. Because the new homework assignment was the start of something new. In fact, I think I'll actually start it in a new project just to start cleaning things up a little bit. So I'll do a commit and push on that. We'll commit.
Does it have to be done in Android Studio, this new project?
No, you could do the first part of it in Eclipse, but then we're going to be moving it over to Android Studio anyway. So, I mean, whatever's fine. Because the first one was just the code, right? I'll probably do it inside of Android Studio, and we'll just do it from the system out for right now, just so we have the logic in there for us. So, in any case, let's just close this. So that should be pushed now. And let's go ahead and start a new Android Studio project. And we're going to call this guy, we're doing binary search tree, right? So let's call this BST underscore CSC300 spring 2016. All right, we'll leave all that alone. And I like to start with empty activities. All right, and we'll let the first screen be called main activity. That's fine. Okay, so homework assignment for today was to implement a binary search tree of integers, right? And it's a binary search tree of nodes. Specifically, I think I specified that it should be nodes, not a tree of trees. And nodes makes more sense for us. So most of you, if you were implementing this, you would have done it the node way anyways. And so every node has at most 2 children. And so we need to be able to add stuff to the tree, and then we have to have the ability to display the tree. And I probably mentioned something about like lexical address. So some sort of format that says, you know, what row column you're in, or something like that. Just something that kind of gives you the ability to prove that the nodes landed in the right place. Okay, so let's go ahead and we'll create a create a Java class, and we're going to call this binary tree. Let's actually just call this BST, binary search tree. Okay, and a binary search tree is going to have a node, which is going to be the head of the tree. So we need to go ahead and give ourselves a definition for a node class. All right, and we're going to have a private int payload. And then we have a node left child, and we have a node right child. And our constructor for node is going to take in a payload. And we're going to set this dot payload equal to payload. This dot left child equal to null. This dot right child is equal to null. Like that. All right, so that's our default node, pretty similar to what we had for linked lists and stacks, except now we have to manage that left child and right child, where before we just had the kind of next node, right? That's where our pointers went, was to next node. All right, so this is our default node here. So now we'll do our binary search tree. So our binary search tree is going to have a private node root, public BST is going to set this dot root equal to null, and then we're going to have a public void add int payload, and so this guy's going to take in a payload, and he's going to try to add that payload to the tree. well, not try, he will add that payload to the tree. So the very first thing we're going to do is we'll create a node n is equal to a new node, and this guy's going to take in that payload. All right, so we have our starting node. This is the guy we want to add to the tree. We'll ask the initial question if we are currently dealing with the empty tree. So if this dot root is equal to null, then we'll go ahead and say this dot root is equal to n. Else, we need to add to the tree. All right, so if we have the empty tree, we'll go ahead and add it. Otherwise, we'll add to the tree. So let's stop it right there for a moment, and we're going to go ahead and write our public void display. And this guy's going to say if this dot root is equal to null, then we'll say system.out.println empty tree. Else, display the tree. Something like that. All right, so let's go ahead and test this and make sure our binary search tree in its simple form works. Right? So we'll create an empty tree. We'll go ahead and just display it. We should see empty tree. All right, so we'll do this in main activity on create. And we'll go ahead and say bst tree is equal to new bst. And then we'll say tree dot display. And we'll go ahead and run this. See how well that emulator. Oh, I'll look at this while this is launching. Well, that's cool. So did you do this with Photoshop, or is this hand drawn? Photoshop. So what, you took the original images and then, so what is it, like a, turned like paint? Like it turned the images into like a paint?
No, I used a photo as reference and then drew that.
Oh, you drew this. So you used Photoshop, but this is drawn. This took time. Oh, I like it.
The printer kind of messed up the colors.
I still like it. It's not terrible. Sissy never photographed well anyways. Gracie was always photogenic. Sissy was terrible. You couldn't barely see her. I'll have to put this. I'm going to put this in my door. I'll put it. So I don't have my schedule up anymore. I'll just put this there. It's a good enough placeholder. Oh, I appreciate that. Better. So you made up for it being late by doing a good job. That's what you're saying.
Oh,
No, yours was good. Yours was good. Yeah. Hers took my mind off of it. Yours was okay. Like every sentence you say, you're downgrading. All right, this guy run yet? Yeah, there's our system out, so we can actually do this. I'm gonna i/system, yeah. So I'll just keep that filter on so we can just see what our output is. I hope that stays. So I guess we'll see if it does. All right, so far so good. We kind of have an empty tree showing up. Everybody's relatively happy with that. Okay, so now let's go ahead and let's be able to add things to our tree. We're going to rely on our nodes to add things to the tree. So if we go back in here, or maybe this should go on my door. Maybe this above, and then this could be pasted on my door. I have to put my name on this, because right now nobody can tell which office I'm in. I think everybody else has their name on their office, so it could be a process of elimination.
You have to fix the typo though.
This is we have computers.
Well, I'll replace that with just my name.
I think that was.
Or you could,
we have Hulk and computers. Hulk
I think it's supposed to be we have computer science.
But Hulk is the computer scientist.
Wouldn't it be have a computer scientist?
Yeah, but Hulk doesn't talk in programs.
Oh, I see. So it's possible it's on purpose.
Possible. Or that could just be like a way out of the background.
Would you rather explain it to everybody?
Yeah.
Fix it.
She makes a pretty good point. Well, I mean, but the punchline is that she's not on the bubble water. So there's possibly I mean, we might be dealing with vegetable lasagna over there. I took your advice and I cut all condos out of Deerfield Beach. I just decided they were all beneath me. So I'm only looking at Boca, and I mean, Boca's good, right?
Boca's really nice. But do you really want to be around that many rich people?
Well, I mean, they're on the golf courses.
I guess. If that's
I mean, I don't really like the people, but I like the golf courses.
okay. If you're there for golfing, then I guess sure. But if you want to go to the beach,
Yeah, I mean, I'll go in the beach like, once or twice a week because my wife wants to take pictures, so I go in there and I frolic. But I'm like a beach bum.
yeah.
I'll spend all day on the golf course.
Okay.
And while I don't typically like the rich, snooty golf people, I'm a very strange person. Like, I am that person, but I'm not.
But you're not.
Yeah, but that's the crowd you have to deal with. That's why I typically like playing with crappy golfers, because they're actually good people. These rich people who spent, zillions of hours playing, they have all this expensive equipment, and they just want to gamble every 5 seconds. That's not fun. I'd rather play with a 30 handicap who's actually a decent human being. And you'd like to hang out with them.
Would she like to take pictures of her, or she just take pictures of you frolicking?
Oh, no, she takes pictures of everything but me. She complains that I'm in her picture. Yeah, no, I think she likes scenery. She likes the palm trees, and I don't know. She takes thousands of pictures.
That's so cool. What kind of camera does she have?
I don't know. You're a photographer person? I mean, if you want, I can connect you to her. She's all into. You can ask her all the questions, and maybe you can give her some tips. She's like a hobbyist, but an aspiring hobbyist. So yeah, I mean, let me know. I'm happy to do that because I don't know what the heck she does. It's above my pay grade. I'm there for golf, fishing, and I'm making her work during the day too. What else is she going to do with her time?
I'm at the beach.
Huh? Oh, she won't go on the beach. She doesn't want to get sand in her shoes.
She takes pictures from like.
Yeah, the sidewalk. Yeah. She actually had, I think it was 2 summers ago, or 2 winters ago, we were down there. I was in the water because I wanted to go in. I usually, every time we go to a new beach, I want to go in for 10 minutes or something just to say I was there. So I've been in the water in a zillion different countries and stuff. But like literally like an 85 or 90-year-old woman told her she was a prude because my wife was sitting there on the bench taking pictures and stuff, and this lady came up and struck up a conversation. When you have an 85-year-old woman call you a prude, sometimes the truth hurts. But my wife, she's cool. She would admit to it. Yeah, she's particular, which should be a compliment to me. She picked me, right? I mean, or is that like her one mistake? That's the bad taste. I think all I have going for me is humor. So when she's upset, I can usually make her laugh. But then sometimes she gets mad at me because I don't care about stuff. Like, why aren't you taking this seriously? Then I have to pretend like I'm taking it seriously. And then she doesn't believe that I'm taking it seriously. It's like, now you're just faking it. So now I have to overreact.
That's what you wanted me to do.
At our last house, we were down in Illinois. We were having some sump pump issue, and rather than call the guy, I decided, I'll take a look. that always works out well. I can tell you from experience. So I'm down there. We had a couple of our friends over too, and so I'm messing with the pipes, and I broke the pipe. I'm just standing there. I'm just getting doused with water coming from the water edges everywhere, and she starts laughing hysterically because I didn't even react. I'm just standing there holding a broken pipe, just getting drenched. I'm just of the opinion that once the damage is done, why get upset about it? When I got in the car accident a couple of months ago on the interstate, when we were on our way to Solly's for breakfast. I mean, I couldn't open my door, but I wasn't going to miss breakfast. You know, so we drove to Solly's, like climbed out of the passenger side. Why be upset about the car? It was already dented. Let's get breakfast out of it. I mean, what, was I going to go home and stew about it?
Did you crash into another car?
I didn't. I didn't crash into anybody. No, I was driving in the right lane on the interstate, and a dude spun out and slammed into like me, the driver's side door, at 65 miles an hour.
Are you suing him?
This gets even better. I thought I've told.
No, I don't think so.
Oh, really?
Never-
Oh, well, this was like 6 months ago, so it might have been in between classes or something.
So it would be in the summer? How would you spin out in the summer?
It was raining. It was raining apparently. I think he fell asleep at the wheel. But he spun out, slammed into the side of my car. But I have a pretty good sized vehicle, so nobody got hurt in my vehicle. Yeah, and his car was not in great shape. But he did pull over. But if I was him, I don't know that I would have. No license, no insurance.
Yeah, you get out of there.
Huh? Yeah. I mean,
Was it daytime?
yeah, it was. Oh yeah, it was like 7:30 in the morning, 7 in the morning, something like that.
You probably would have gotten caught.
Oh, I don't know. I'm just thinking out loud, but he stopped, and I called the police, and just said there was an accident, send somebody over, and he finally came up and said, is everybody okay? And so thank God everybody was fine, nobody got hurt.
You should freak him out. Be like,
But I've lost vision in my right eye.
That's probably when he takes off. Then he's like, oh no.
Well, from his perspective, that doesn't make it any worse. He doesn't have insurance anyways. What does it matter if you're paying hundreds of thousands of dollars in medical bills or $20,000 in car payments? Realistically, if you don't have insurance, there's probably a decent reason for it. It doesn't matter what your debt.
So who paid for your car then?
Well, I have insurance. So my insurance paid to fix my car. I had to pay a $500 deductible for somebody else hitting me.
You could probably sue him for that.
I'll probably get the deductible back because the insurance company tries to get as much money out of them as they can. Who knows? I mean, it happens, right? So I'm not going to lose sleep over, $500. At least nobody was hurt, and the car's fixed now. It does suck. The car was 6 weeks old at the time, and I hadn't been in an accident in I don't know, ever. I guess I've never really. At one time, somebody backed into me, but not like a real. I didn't even know how to handle it. So I took this broken vehicle into the dealership and okay, how does this work? It was like $18,000 to fix the car. They replaced both doors and do something with the frame. I don't know what they did.
Airbags are expensive.
No, the airbags didn't go off.
Oh, see, my car.
That would have been awesome though.
Airbags went off, and that totaled my car. The fact that the airbags got off because the airbags were worth more than my car.
Yeah. But I mean, the car was almost brand new, and it's like a $55,000 car, and basically, it was almost half of the car to fix it. Now I'm driving around in a car that's been in an accident. I'm not gonna be able to trade that. Just drive it into the ground, see what happens. I wouldn't have gotten the new car in the first place. They just had somebody who wanted a used Flex. The car I have now is the same car I had before, just one model year newer. So I like the car, no big deal. But the punchline was I just kept going to breakfast.
Like with your car dented and everything?
Yeah, I couldn't open the door.
So you just drove around and then got out the passenger side?
Yeah, I climbed out the passenger side, climbed in the passenger side, which is, I know I seem
Do you have a sunroof? You should
petite,
find
but
out.
in real life, I'm pretty big. Do I have a sunroof? Yeah, the whole roof of my car is a sunroof. It's all glass up there.
Oh, yeah. And then you got like the 4 little ones in the back.
I guess I don't use them. It came with the car. That wasn't something I was shopping for. Just that happened to be on the car. So I don't open it. But I assume you don't use sunroofs. Yeah, it's damaging,
My car had a sunroof.
but you don't open it.
No.
So you're mostly in vampire mode most of the time. I get it. It makes sense. Hence you want to get the finger monkey. I mean, it goes hand in hand.
Apparently, they make you buy 3 of them at least if you're buying them because they're social animals.
You think you buy them in bulk? Doesn't make any sense.
And Wisconsin allows them, but not Illinois. So even if I bought them, I wouldn't be able to bring them back home.
Well, what if you bought them in Wisconsin and then you happen to travel with them home and then you just play dumb?
You can only have them in Illinois if you bought them before 2011.
How do they know when you bought it? Nobody keeps receipts for their pets.
Since it's an exotic pet, you have to get a license for it. So
But the chances of you getting caught are pretty slim.
oh yeah, as long as I don't do something stupid.
Yeah. Like going to a pet store and just release them and they start eating the fish.
Take them to dog training class on a leash.
Well, I don't know if I would do that. Dogs might look at that as a snack. That might not go so well, but you do the fish tank thing, that would be funny. You know, I don't know that a goldfish is going to do a lot of damage to that. You got this little monkey in there swimming around. It'd be awesome.
You couldn't swim.
Well, why wouldn't they be able to swim?
Can monkeys swim?
I would think
They
so.
just swing from tree to tree over the top of the river. They don't actually go through the
Seems
river.
like monkeys would like to frolic in the water. Yeah. Why wouldn't a monkey be able to swim?
Most animals can swim.
Yeah, see? You can't swim though, can you? You haven't had practice outside swimming? Can you swim?
I can swim. Yeah.
Do you, I mean, are you just assuming or you know?
No, I know I can.
Is this a hypothesis or has this been tested?
After a quick Google search, monkeys can't swim.
Yeah.
See? So do the pet store thing. That'd be hilarious. Videotape it though. You gotta push it to the YouTube before they arrest you.
Habitat is like what?
In my house.
Human?
Put a couple pieces of wood in there. They can play on
Are
it.
you kidding? It would
We just
die
get a small pet
instantly.
cage. I was looking this up.
It would die instantly.
It's too cold in Wisconsin for it to survive.
Well, you
I'm
don't-
thinking
you don't
about
take
its
it outside.
habitat in the jungle, and it's really hot and humid.
Well, there's plenty of people who have snakes and stuff like that. That you know, you keep it indoors and you put it under a lamp and that kind of stuff. You create the habitat
Yeah, just convert your basement into a jungle.
to a rainforest. Yeah.
But you wouldn't be able to like take it to school or anything like that.
I don't take my dog to school.
I'm just thinking, if you got one, I bet you want to bring it here.
It's true.
I can live off campus or just keep it in my dorm and never let my
Well, now that you know that it can swim, all you have to do is put it in a little jar
I can keep
and
it
put a
in
little
my-
water in there and just warm up the water. You can like put it on like a coffee, have it on a coffee pot thing that it just keeps the water like warm. And you hit the wrong switch, the monkey's like, this class just turned into how to torture a finger monkey. All right, so let's add a node. So that went south so fast. All right, so if we have a tree that has something in it, that is the root node is equal to something, and let's say we want to add a 4. What we're going to do is we're going to go ahead and we're going to add this node to this node. We're going to ask the node to add the node to itself. Okay, so we know the node is there. So if I'm this node 5 and somebody passes in, you know, we call add node, and now I have this new node. I say, okay, well, my job is to add this guy. Well, so I'm going to ask the question, should he come before me or should he come after me? So you're going to go to the left side or is he going to go to the right side? In this case, this guy is less than or equal to 5, so he's going to go to the left side, right? So I have this node in my hand. I've decided if he goes anywhere, he goes to my left side. So now I'm going to look down and say, do I currently have a left child? If I don't, I'll place him. If I do, I'll ask my left child to place him. Make sense? I'm just going to pass the buck. So come back in here. Work.
Sorry,
Go
if
ahead.
it was equal to 5, which way would it go?
Well, you can decide. Typically, less than or equal to goes to the left. Greater than goes to the right. But if you want to flip-flop that, there's nothing wrong with it. Just stay consistent.
Okay.
Yeah, don't randomize. Your tree has to have the decision should always be the same. All right, so we're going to teach our nodes how to add a node. Actually, before we can actually do that here. Public void add. This guy will take in a node n. Now, if somebody passed this to me, I know that I'm real, right? So he's definitely not going to take my place. I'm just going to ask the question, which side should he go in? So if n dot payload is less than or equal to this dot payload, all right, and this is another, well, let's make these guys private too while we're at it. This is another lesson on public-private protected. So even though payload is a private variable, we can directly access n's payload because we are in the node class. So we don't actually have to have a getter yet. Eventually we probably will. We're going to want to be able to get the values of our nodes from outside of the node class. But so far, we don't have to have a getter because we can directly ask n for his payload because we are currently inside of the node class, even though we're in a different instance of the node class. Make sense? All right, so if n's payload is less than or equal to this dot payload, we will add to the left. Else, we will add to the right. All right, so for adding to the left, what are we going to do? Well, first we're going to ask, do we have a left child? If we don't, welcome, you're my new left child. All right, so if this dot left child is equal to null, this dot left child is equal to n. You're my new left child. Otherwise, this dot left child dot add n. We'll ask our left child to go ahead and add this guy. Make sense? So this guy is going to reference, I think last time, Plinko from one of the shows, Price is Right or Let's Make a Deal. I don't know which one it's from. And it's Price is Right. Yeah, you spend enough time indoors, you probably know that. Yeah, I trust that answer. Okay. Don't you think the finger monkey's going to get bored watching all these game shows and soap operas?
Soap opera.
I'm just making an assumption. It's a fair assumption.
I just watched 3 times in a row.
You just watch what?
Sports Center like 3 times in a row.
Oh, yeah. See, now he's like trying to act all tough. Well, I just watched Sports Center.
I honestly watched too much. My roommates complained about that. They complain they want the window. No way to get a glare.
Well, you'll have to close the window if you have one of these monkeys. Will run out the window.
No, I mean like the blind.
I have to keep the windows closed because Mr. Gonzales keeps trying to escape.
Isn't it still handled?
What?
An elf on the shelf?
Well, he's not an elf on the shelf. He's made in the image of the elves on the shelf, but you're allowed to play with them. The real elf on the shelf, the kids aren't allowed to play with them. That's a rule. The elf on the shelf he's keeping an eye on them to make sure they're good. And every night he reports back to Santa. And then he's in a different location when he comes back. But that's only during the Christmas season.
What's he doing the rest of the year?
What do I know? Am I an elf on the shelf manager? I could be? Because I'm fat and could be Santa?
No.
I get it. I get it. It's this message received.
No, there are people on Craigslist that like post ads and like, for $100 I'll dress up as an elf on the shelf and come sit in your house.
That's creepy.
Well, yeah, especially you would probably do it for free.
Don't let
Like, it's creepy to take money for that. Nobody should take money for that.
I know there's been some mistakes to like pose as fake dates for like people who want to bring someone home to their parents.
Yeah. But I've seen a whole bunch of pictures online of people putting, whenever it's usually the guy. So when the dad's in charge of the elf on the shelf ends up doing funny things. Yeah, but Mr. Gonzales is not an elf on the shelf. He's part of the plush things that the kids are actually allowed to play with. He's a friend of the elf on the shelf, but he stays. He doesn't. Well, he keeps trying to escape. One of these days he's going to come in and help me teach, probably.
This is getting kind of creepy.
Huh?
This is getting kind of creepy.
Well, you wouldn't like to meet Mr. Gonzales? He's been on cruises. He's been all over the world.
Bringing Mrs. Gonzales? Well, she's not Mrs. Gonzales.
Yeah, not Mrs. Gonzales yet. That's in the cruise next week.
So she can be Aunt
Right now, it's just Aunt
Gonzales.
Jemima.
So is it going to become Aunt Gonzales? Gonzales?
No, Aunt Jemima Gonzales. She's hyphenating.
Just this story.
All right, so let's finish adding our nodes. So if we're going to go to the left, if the node we're trying to add should be on the left, we're going to say, do I have an opening? If yes, we'll just add them. If I don't, we'll ask my left child to add them. Else, it's going to go to the right. If this dot right child is equal to null, I have an opening. So this dot right child is equal to n. Else, this dot right child dot add node n. All right, so this should get the nodes added to the tree. It's recursive like, because actually, so we're in the add node method here, right? But when we call add here, we're calling it on a different node. We're asking our left child to call his add method. So it's the same method, but it's for a different person. So we're currently in this dot add. This would be this dot left child dot add. So a different node is adding him. But it is recursive-esque.
So it's the linked list of recursion.
Linked list of recursion. I don't know what that means.
Like, there, from what I understand, the linked list is you have the thing, and then it has like the pointer that points to whatever the next one is. So like, it doesn't directly know about the one next in line, but like if it follows.
Yeah. So this, I think this is what you're saying. Left child's add does not know about the parent. So as soon as I leave the premises here and go to the left child's add method, all this stuff is now gone. He doesn't know about the current this, because the new this will be the left child. But it certainly looks like recursion, and you can make an argument that it's like recursion, but it isn't actually putting this method on. This method's not expecting anything in return. He's not expecting an answer from this. He's just expecting the job to be done. All right, as opposed to recursion, which usually is like, okay, well, my answer is going to be this times whatever this guy gives me. So I need to wait for him to finish. Okay, so this guy, he will block until this line is done, but he's not doing anything else after this. All right, so this should get something added to a node. All right, so now we should be able to add stuff to our linked list, no harm, no foul, and or to our binary search tree, and the tree should get filled up with stuff. So let's test that and make sure everything kind of falls into place. We won't actually be able to see anything yet, but we can go ahead and we'll create a random r is equal to new random. And let's see, what do I need to do? I need to do that guy. And then we'll do for int I is equal to 0, I is less than, let's do 10, I plus plus. We'll say tree dot add r dot next int. Let's just do 100. That'll give us a random number between 0 and 99. So that'll Plinko into the tree, wherever it's going to end up going. And then our tree is going to have stuff in it, and we'll prove that here. We'll go back into our binary search tree, and for right now, we'll just say system.out.println, there is stuff in the tree. All right, so even though we're adding 10 things, we're just at this point detecting that the tree is not null. So we'll go ahead and run this. We'll see if my filter sticks. Right, there is stuff in the tree. Oh, I left it inside the loop apparently. I didn't leave it inside the loop.
I think you put it in the add method, not the display method.
Well, I'm displaying right here, so here's the tree. Oh, I did. Yeah, thank you. I was testing you. You're the only one that passed. There we go. All right, there's stuff. Okay, so now we need to manage the stuff, right? All right, so what we're going to do is, in order for a tree to display itself, we're going to have to ask each individual node to display themselves. Now, we can play the game where a tree, we try to draw the little diagonals and it starts looking like a tree, but that becomes very scary very quickly as you start having really large trees. And we can actually pull this off in Android more easily than we can with text, but it still would become unwieldy and probably not a great use of our time. So we're going to rely on this lexical address thing to give us kind of that relative position of our nodes, just proving that they're in there and not spending all our time displaying a tree. So we're going to go ahead and we're going to ask our node to display itself. So we'll come in here. We'll just do it up top here. So we're going to say public void display. Now, what we're going to do is we're going to have display take in a, let's say, int. Let's just call it pause for right now. Okay, it's going to take in an int pause. And this is the level in the tree where this guy lives. All right, so the first level guy is going to be pause 0. So he'll display himself. So that's the first thing we'll do. We're going to say system.out.print. And we're going to go ahead and we're going to say this dot payload concatenated with. Actually, let's do it all in a. I think I kind of suggested maybe we do it in parentheses. So we'll have a parenthesis followed by this dot payload concatenated with a. Well, it'll end up having a closing parenthesis, but we're going to concatenate this with a colon. And we'll have this guy, for right now, concatenated with pause, concatenated with the closing. So right now our address is just going to tell us, let's see, I am missing a dude. Yeah, thank you. Okay, so right now this is just going to tell us what row the guy is in. All right, so we just get one of the two address pieces. So we'll go ahead and get our left and our right. Well, we got our self first, and then if this dot left child is not equal to null, if we have a left child, then we'll go ahead and say this dot left child dot display, and we need to give this guy pause +1. Then if this dot right child is not equal to null, this dot right child dot display pause +1. All right. So what we'll do here is we'll just I'll throw a tab at the end of this just so we'll have a bunch of tabbed parenthesis things for our nodes for spacing. Okay. So let's go ahead and we'll ask our binary search tree to display stuff. We'll say this dot root dot display 0. He's at level 0 in there. All right, so he'll display himself, his payload at his position. Then he'll ask each of his children to display themselves at their positions. But right now we're just showing row. have thought something would have displayed by now. Main activity. Here's our tree, here's our random. Fill up our tree with some stuff. Tell our tree to display itself. Here's our tree. We're going to tell the root node to go ahead and display himself. The root node for display takes in a 0. He's going to print out his payload, followed by, I know what the problem is. Print isn't a thing in Android. We can't do a print, so we have to do print lens. That's fine. Now it'll display. All right. And so we'll do sys out. All right, so there is our 0. So that printed here, and then we asked if our left child is not equal to null. We should have left and right children. So let's follow that in here. So we'll tell our tree to add some number. Here's our tree. We're going to add that number. Here's our payload. We never actually add the number. This .root .add, and we were never actually adding the number to our tree. Now it should show the stuff. All right, so we have a 66 at 0, a 30 at 1. We should have something else at 1 down here, looks like. 93, 2, 3, 4. So we're seeing kind of the depths go down there. All right. Now, we would like to know where in that tree structure, though, these things live. So how do we give the lexical address of these? So if let's put another value here. We'll do this one as a 6, and then we'll put another value here. This is going to be a 4. Put another value here. This is going to be a 5. Let's leave it like that. So the lexical address of this one, right now we have this guy at 0, both of these guys at 0, both of these guys at 1. That's our current setup. But now we want to kind of give some sort of indication about whether something is the left or the right child, right? So this guy is neither left or right. So this guy's going to be root. This guy would be a left child. This guy would be a right child. So we need to be able to pass in the type of child this person is at that level. Does that make sense? So let's start with that. So when we display in node, we're going to take in a pause, and we're going to take in a char type. All right. So when we do left child, we'll pass in an L. Right child, we'll pass in an R. And when we say pause here, we're then going to expand that out and put a colon. We'll put a space between those. We're fine. Then type. Then All right, so payload followed by a colon, followed by pos, followed by a colon, followed by type. And this should give us some feedback. And then when we call the left and the right node, we'll have L and R as the type. When we originally called this from binary search tree, we're going to pass it the row, and then we're going to pass it the type is root. Except that needs to be a char. So maybe we call this guy T for top. Good enough. And it's got to be a char. So now when we run this, we should get whether something is the left or right node. But we don't know who his parent is, right? Well, we don't have that information. So here's the top of the tree. This guy has a left node, who also has a left node, who also has a left node, as well as a right node. So here's level 2 right. All right, so now how do we tell which side of the tree we're on? We deal with lexical address. How do I differentiate between this left node and, let's give us, so we'll do another 6. And this left node. This guy's a left node, this guy's a left node. Or maybe more directly, how do I differentiate between this guy and this guy? This is row 0, row 1, row 2. So this is row 2 left node. This is also row 2 left node. How do I differentiate between those two guys? To find out where in the tree this particular node lives, so that we could recreate the tree if we had to. All right, well, what about their parent?
Their parents are different, so you can kind of figure out.
Okay, well, when we're printing this guy out, right now we're printing out, let's just put the string in. This is going to print out 6 colon 0, 1, 2 colon left. And this guy would have the exact same value, except it's a 4. But that 2 and the L don't give us information about where they're located in the tree. How do we modify this to give us that information?
If its payload is larger than the root, wouldn't it be on the right side of the tree?
Okay, so we can make that assumption, which side of the tree we're on. All right, so what about where they are relative to the parent before them? Because we don't necessarily, this guy doesn't necessarily know about this guy. When we display, we could build up a string rather than print, where we have the parents getting filled in. Then it would start becoming more like a recursive call, because we are relying on those values. So we kind of build up a array. Well, not an array. It would be a kind of a nested parenthesis type thing. Let me show you this. So we could have display. Actually, this will be a fun way of doing it. Take advantage of something here. Public string to string. Actually, we want to do this in Node. So we're going to write the toString method in Node. And this guy's job is to return a string. So we're going to start off with string s is equal to, put this string in here. So we're going to build that, that string. Now we need to be able to tell this guy what his pos is. ToString is going to suck for that. So let's go back to display. But this guy's ultimately going to return a string now. So we'll go ahead and say string s is equal to this dude. All right. So that's the starting point for S. Now, if this guy has a left child, we need to give him his left child. So when we build this, we're probably going to want to build something that looks something like this. So for this node right here, currently it's going to be 4, 1 left, right? That's what that guy would be. Well, what if we did, and then this guy would be 4, 2 left. But what if what we saw here was something that looked more like this? 4, 1 left. And then inside of that, we had a left and right child. So left child would be 4, 2 left. Right child would be 5, 2 right. So just in that little microcosm there, that's our subtree right here. Before that, this guy up here is 5, 0, top. So this is 5, 0, T. Then we have 4, 1 left, who has a 4, 2 left, and a 5, 2 right. So this guy right here is his own tree. So that's the inner tree. The outer tree has a left child of what I have highlighted there. That's the left tree that's hanging off that guy. Here's the root node. The right tree that's hanging off that guy. Steal this. Is going to be 6, 1 right. And that guy, that's fine. And he's going to have a left tree of 6, 2 left, and a right tree of null. Yeah, that's right. And this guy doesn't belong on this side. That was for my copying. So this guy right here is the right tree of the root tree. So now the question is, let's kind of abstract this just so you see what the format is here. We really have a payload followed by left and right. Where left and right is a payload followed by left and right. Where left and right is a payload followed by left and right. So we actually don't need to keep track of left and right anymore because we know that the first thing following a payload is his left node. And the next thing is his right node. Does that make sense? So now we can get the full lexicographic address. We can get rid of type here. We can actually get rid of pause. We don't actually need to know what level we're at. So we're going to get our payload, and we're going to follow that by our left tree. So let's just leave it at payload for the moment right here. If our left child is not equal to null, then we're going to return S concatenated with our left child dot display. And we probably need to have a little space after this guy. So we'll start off with opening parenthesis, this dot payload, a space. If we have a left child, we'll go ahead and return whatever our current string is concatenated with whatever our left child creates for display. We're going to do the same thing down here for our right child. Same thing for our right child. Then, in the event of an else here, we're going to set our right child equal to the null value. Now, we don't want to return these yet because we're not done building this, right? So when we're getting our left child, we're going to do something like this. We get our right child, we're going to do something like this. But if our left child doesn't exist, then we'll say S is equal to S concatenated with, let's just do a capital null. There's nothing there, right? Similarly, we'll have that same S over, same else over here. And finally, we're going to return S concatenated with our final closing parenthesis. So when we call display, we'll get the ball rolling on this string. We'll concatenate onto that string whatever our left child thinks his display should look like. Otherwise, we'll put a null on there. We'll concatenate onto that string whatever our right child thinks his display should look like, because our syntax here is payload left right. Finally, we'll cap it off with a closing parenthesis and return that value. So we're allowing our tree to create itself. We no longer have to give it pauses. Instead, it's going to basically be a visual data structure for us. We just have to kind of decode it to if we were to draw it out. So this should give us a map of our tree. Oh, I'm not printing it. Sorry. Because this guy ultimately returns a string. So we need to print that string it returns. So display is probably not the best method name for that, but we'll go with it. And this is going to give us a lexicographic address. Well, a lexicographic representation of our tree. So here's our tree. Our root node is 4. His left node is null. His right node is this whole guy. So this is a right subtree. Does that make sense? So we can paint this out. What we'll do on Tuesday is we're going to look at how to traverse a tree. Do we want homework or no homework? Last time I didn't give homework. I didn't get like a real great effort for cat stuff. All right. Since we will be having our midterm next Thursday, midterm will be next Thursday, I would take the weekend and start reviewing the material that we've done so far in preparation for the midterm. We'll talk about it on Tuesday so you know what's coming on Thursday, and then we'll go from there. Sound good? So your homework for the weekend is to begin preparation for the midterm, looking at some of the introductory material we talked about for data structures, and then specifically how some of these things work. All right? I will see everybody on Tuesday. And I'll go ahead and put this repository up.